Okay, so if we want to evaluate that expression. Where is that? Okay, right there. So we're trying to evaluate 8 times the tangent of 27. Here's the most common mistake people make in math, I think, is when you're doing trig stuff, by far, is just putting that in there without knowing if your calculator's in the right mode. There's 2 different modes that we're going to use. For you guys right now, we're always going to be in degrees mode, but later on, like in calculus, we'll typically be in radians mode. Those are different ways of measuring angles, radians versus degrees. So you want to make sure when you go to mode that always you're in degrees mode for these kinds of problems, right? So we already are. So then all I've got to do is just go 8 times tangent, and then notice it's going to open up a set of parentheses because it wants to know what are we feeding the tangent? Well, the angle, 27 degrees. And so there's my answer right there, okay? So it's roughly 4.08, okay? Make sense? That's just a calculator number, right? That's not one you would know. That's just a calculator number. Questions? Okay, let's try another one of those. Try this one. Everybody set this up. See if you can set up a ratio here so you can find PR. So draw the picture, add an X for your unknown, and set up a ratio. Okay, what do we got? So that's our X, right? Now, later on, I'm gonna throw some of these at you once we've talked about sine and cosine also, and you have to pick which one makes sense. Now, here's how we can approach that. If we think about this in terms of SOHCAHTOA, if we're trying to find PR, and the one angle we're given in this case is 54 degrees, relative to the 54 degrees, how would you describe the side length that we're trying to find and the one that we're given? From the perspective of 54, this is what? Opposite and adjacent. And so then we would say, okay, out of SOHCAHTOA, tangent is the one, TOA is the one that involves opposite and adjacent. And so we'll just write the tangent relationship. So what's that going to be? Tangent of what? Okay, 54 is equal to what ratio? X over 4.6. Good. So then PR, which is X, just equals what?
4.6 tangent of 4.
And that's just a calculator number. Right? Go ahead and calculate. Okay, make sense? Okay, how about this? This is different. How could we find the measure of angle A? So from angle A's perspective, we're given this time 2 side lengths. Everybody agree that from A's perspective, we got opposite and adjacent? So we'll start with the tangent relationship, right? So tangent of angle A is equal to the ratio of 6.8 over 3.0. Everybody agree? Opposite over adjacent? Okay, does anybody know what the next step is? How do we solve for A this time? The previous two examples were pretty simple, right? Because we were just isolating a variable like we always do, no big deal, right? And then just plugging some numbers into our calculator. How do you suppose that we're going to deal with something like this, where the variable we're looking for is actually inside the tangent?
Reverse.
Okay, so it's going to be the inverse tangent, or the arctangent. We've got to undo the tangent function, just like we would if we were doing something like, let's say we had square root of x equals, 4, or something like that. In this case, we'd have to undo the function which the x is inside, right? So we'd have to square both sides, right? So how do we do that? Well, that's once again a calculator issue. So we'd say that the inverse tangent of tangent of A equals the inverse tangent of the ratio 6.8 over 3.0, and inverse tangent cancels tangent, so we just get an A, right? So you could probably skip that middle step. We just end up with A equals the inverse tangent of this ratio. And once again, that's just on our calculator. So how do we do that on a calculator? Not a big deal. We just go, notice that behind the sine, cosine, and tangent are the inverse functions, right? So we hit second tangent, and then we're just going to put in the ratio 6.8 divided by 3.0, and it's going to give us back that answer. What are the units of that answer, do you suppose? Degrees. Yeah, right, because an inverse tangent does the reverse of what a tangent would do. Instead of feeding it an angle and getting back a number, you're going to feed it a number and get back, the measure of an angle, right? So the measure of angle A, which in this problem they just called A, which is fine. So A is equal to about, roughly, so I should put those kind of approximately equal sign, 66.2 degrees. Okay? Okay, so what if we wanted to build a ramp here then? We want to build a ramp that carries people up to a height of 1.4 meters. If we want to know what the angle of the ramp is going to be, what additional information would we probably need to know here? Yeah, we need to know the horizontal. Let's say for example, if we found the horizontal length of the ramp right here, right? For now, we'll just call that x. Then we could find the angle pretty easily, right? What's going to be the trig ratio that would relate those two? Tangent A is 1.4 over x, and then to solve for A, if I were able to fill in a number for x, I can just take an arctangent or an inverse tangent, same thing, right? Okay? All right, good. So how about something like this? Now let's switch to sine and cosine stuff. So what if we know that the cosine of an angle is about 0.899, okay, roughly. Write the sine of a complementary angle. Okay, so let's draw a triangle here, once again. Just a representative triangle, doesn't have to be exact. So they're telling us this is going to be maybe 26 degrees. How could I write the other side lengths in a way that's going to represent this situation? What's cosine the ratio of? Okay, good. So if we go back and we think of so we're doing cosine, so that's the ratio of, what is it again? Adjacent over hypotenuse. Okay, so how can I write this as a fraction? 0.899. A bunch of ways I could do it, but let's just pick a really easy one. We could, or we could even just go point, anything divided by 1 is a fraction, right? So I could even just write it as 0.899 over 1 being the hypotenuse, right? And so the sine of a complementary angle. So what's going to be the complementary angle in that triangle? What's it mean to be complementary? Going back to geometry, it's been a while. Complementary means they add to 90. How do we say they add to 180? Supplementary, okay. So the complementary angle, if this is 90, would you everybody agree x is going to be the complementary angle? What's going to be the magnitude of x? What's the measure of angle x going to be? 64. Okay, because they have to add to 90, right? So then we could say the sine of 64 degrees equals what? What's the ratio for sine? So what's that? 0.899, right? Everybody agree? The ratio of opposite from x's perspective, that's opposite and that's hypotenuse. Okay? So that just betrays another little relationship that you guys will get a lot of mileage out of, like next year, for example. Not so much this year, but sine of one angle in a right triangle is always going to be equivalent to cosine of the complementary angle and vice versa. Okay? Okay? How about something like this? Let's write the sine and cosine of angle A and then the cosine of angle B. Everybody just do that real quick. All right, so what do we got here? Jill, what's the sine of angle A? Ratio of what?
It would be 12 over 13.
Very good. Opposite over hypotenuse, right? Okay. What's the cosine of angle A, Ruby? If you're not sure, always just write down SOHCAHTOA, and that tells you everything you need to know. So we want cosine of A. 5 over 13. Good. Jason over hypotenuse. Very good. And let's see, Maddie, what's cosine of angle B?
5 over, or cosine?
Yeah.
5 over 13. Or, no, adjacent, 12 over 13.
12 over
Sorry.
13. Good. There you go. Good. And notice this relationship again, right? Okay, sine of an angle and the cosine of the complementary angle give you back the same ratio. Okay? Not that, I mean, you don't need to, that's not some hugely important thing, you gotta just remember, it'll always be that way, and you'll recognize that easily soon. Okay, how about this, solve for x? So, real quick, when we're thinking about this, we always want to kind of latch on to the angle that we're given, right? So we know there's a right angle, so we got a right triangle. We're given angle 37, we're given this angle C, which is 37 degrees. Now we could fill in the blank with A if we want to, but there's no need to. We're fine with just using angle C. But from C's perspective, you got to figure out what's the trig ratio that's going to be helpful to us. If we're given one side length and we're trying to find another one, and then just go from there, okay? Go. All right, Luke, what do you think? For the 37-degree angle, for angle C, which trig function is going to be helpful? So that would be, tangent would be opposite over adjacent, but we don't know the adjacent. So what other one? We know We're trying to find x, so that's the opposite, and we're given 15. Which one is that? Okay, so which one's it going to be then? Oh, you agree? Sine? Because it'd be opposite and hypotenuse. Okay, so then the sine of 37 degrees equals x over 15. So what's x?
15 sine 37.
15 sine 37. Calculator number, right? No big deal. We would just multiply each side by 15. Throw it in your calculator. Okay. How about that one? What do you think? Matthew, from the perspective of the 53-degree angle this time, which trig relationship should we start with?
Sine.
So sine would be, let's write down what these are again. Right, so we got so there's the 53. So let's see, we've got x, which is, what's that going to be relative to the, that's adjacent, okay. And then 27 is what?
Hypotenuse.
So which one uses an A? Oh, there they are, A and H, right? So that's going to be cosine. Cosine of 53 equals x over 27. So just multiply each side by 27 and we got it. Calculator number, right? Okay, what about one like this? Last one. What about one like that? From the 75's perspective, everybody agree that's cosine?
Yes.
So cosine 75 equals 14 over x. So what do I do there?
X equals 14 cosine 75.
Okay, in one step, remember, I can exchange diagonally, right? Same thing as cross multiplying and dividing by the cosine. Everybody agree I'm going to get x equals 14 divided by cosine 75 that time? Once again, just a calculator number. Okay, make sense? All right, here, hang on. Before you go, on your way out, grab one of these. We're going to do paper and pencil on this one. Everybody grab one of these. This is your homework over trig stuff.